Right, welcome back to the online lesson to cover up on the redox reaction that we didn't manage to finish up in class. Okay, so just a quick recap. I think in the previous few lessons, right, we talked about how can we determine whether something goes through oxidation or reduction. So for instance, we can take a look at whether something actually gain or lose oxygen, whether it lost or gained hydrogen, or whether it lost or gained electrons. And this can be summarized using this very short mnemonics. Okay, do you still recall what's the mnemonics? Right, how do we tell that something has gone through oxidation? Yes, we can say that oxidation can be represented when the substance actually gain oxygen. So GO stands for gain oxygen. Right? And of course you know that it's called oxgolate, right? So now, what does this LEH means? Okay, this LEH, right, actually stands for two things, to be honest. It actually stands for to lose electrons or hydrogen. So basically, right, what you actually seen so far was how you can look at whether something gained or lost oxygen to see whether it's undergoing oxidation, or whether it lost or gained electrons or hydrogen to tell whether it went through oxidation or reduction. So if this is oxidation, right, so basically all you need to know is the opposite will be reduction. So for instance, in reduction, right, instead of gaining oxygen, you will lose oxygen. Instead of losing electrons or hydrogen, you will actually gain electrons or hydrogen. Right, so it's the opposite in this case, okay? So what I'm going to do now is I'm just going to cover up some of the practice questions that I asked you to go back and do. Okay, so let's take a look at some of the questions. So I believe that this is one of the questions that question 2 and 3 we actually went through in class already, but we didn't mention about this thing called the oxidizing agent or reducing agent. So let's take a look at the top of page 2. You realize that there's actually 2 points here that I didn't cover in class. So for the first point, right, it actually tells you that a substance that is oxidized, okay, if something goes through oxidation, okay, we actually call them a reducing agent. Now, what is the meaning of that? Okay, let me cover the other one so that you can see a better picture of what is the comparison. If a substance is reduced, we actually call it the oxidizing agent. Right? So you have these two terms over here. Now, to understand what they mean, right, actually we just need to understand how does a reaction work in this case. For instance, if a substance is being oxidized, it has the ability, because it's being oxidized, right, it could have actually cause something to be reduced in the process, right? So like in a typical redox reaction, when something is being oxidized, something else will be reduced. So for instance, in a redox reaction, right, if the substance is being oxidized, it must have caused the other one to be reduced. So we say that it actually has the ability to reduce another substance. Hence, we call it a reducing agent. Right, you see a link over there? Next, if a substance is being reduced, it means that it actually has the ability to oxidize another substance. Hence, we actually call it the oxidizing agent. So this is a new terminology for you, and you actually see this quite often in the questions lah. Okay, so basically, a substance that is being oxidized, we call it the reducing agent. It's the opposite lah. Okay, and something that's being reduced is the oxidizing agent, which is the opposite. Okay, so this is something for you to keep in mind. Okay, we'll go through a few practices so you know what we are talking about. So let's take a look at the questions that didn't manage to go through in class. Say part C. Okay, let's take a look at part C. So the substance that's being oxidized in this case, the HBr, which is the hydrogen bromide. Okay, why so? Because if you take a look at the HBr, right, it actually lost hydrogen to form your Br2, which is just bromine, right? So because HBr lost hydrogen atoms to form Br2. Remember the way we write, there's always a before and after. So before it was HBr, after it was Br2, and the middle we justify by what exactly happened to it. Okay, and in their case, the one that is being reduced in this case will actually be your SO3. In the SO3 case, right, if you take a look at it, it actually became SO2, right? So that is a losing of oxygen. I know it's quite small, but it lost oxygen. So basically the substance that's being reduced is SO3, okay, because SO3 lost oxygen atom to form SO2. Right, same thing. I also talk about what happens before, what happens after, and what actually took place in order for that process to happen. So now, what is the substance that is called the oxidizing agent? Like what I said just now, the oxidizing agent is the substance that causes something else to be oxidized. So itself must have been reduced. So it's actually your SO3. The reducing agent in this case is the substance that caused something else to be reduced, and therefore itself must have been oxidized, and it is actually hydrogen bromide. Okay, so take note, causes another substance to be oxidized. Okay, that's the meaning of an oxidizing agent. And in this case, HBr, hydrogen bromide, is the reducing agent because it causes another substance to be reduced. Okay, so far? Right? Okay, now let's take a look at the other examples that I told you to go back and try out. Okay, this was the part that I ended off quite quickly. I actually needed you to go back and try and practice in terms of whether it lost or gained electrons. But I did tell you that actually for this part, right, you do need to know a bit about how your ions work. So for instance, if you look at this MgO, okay, you must be able to tell that there's a metal and a non-metal inside first, which tells you that, okay, this is an ionic compound, because with that, you can deduce that there's actually an Mg2 plus and there is a O2 minus ion inside, although you don't show it over here because you already balanced out the charge already, right? So what happens is you realize that this magnesium actually became Mg2 plus and this oxygen actually became O2 minus. So now comes the tricky part. How do I know whether electrons are gained or lost? Okay, electrons are negative. That's the first thing you must know. Which means that, right, when you become more negative, like this oxygen, right, you actually gain electrons, because you gain more of the negative electrons. Whereas if you become a 2 plus, if you become more positive, it's actually due to you losing electrons. So in this case, we say that magnesium, because it lost electron, right? And you remember the ox gole, so this is a type of oxidation. So we say that magnesium is oxidized. On the other hand, your O2, you actually gain electron, so we say that it's being reduced. Right? Of course, there's a lot more for you to elaborate on why, the reason why. Okay, but I'm just telling you that this is what happens. So with that, right, let's take a look at some of the examples. Okay, we went through one briefly in class, so let's just finish up with what are the missing keywords. Okay, so the substance that's being oxidized in this case is zinc, because zinc went from just Zn into with a 2 plus charge, right, zinc 2 plus. And of course, the substance that's being reduced, as you can see over here, it went from a positive hydrogen ion to just H2 as an element which has no charge. So it actually gained electrons. Right, when you gain electrons, it's actually a type of reduction. So the substance that's being reduced is the H plus. Okay, take note that the substance that is being reduced or oxidized, right, are always the reactants, right? Because there's no point saying that, oh, it's the product that got reduced or oxidized. It doesn't make sense. So now, because the substance is reduced is H plus, right, we must be able to explain. How do we explain? We say that H plus has gained electrons to form H2, right? So similarly, I had a before, I had an after, and I have what happens in between, right? So these are the key words that you need to explain. So looking at the other example now, right, very quickly, I believe that you have already taken a look and you should have attempted. If you have not, maybe you would like to pause the video right now and try it out by yourself. If not, let's take a look quickly. Magnesium went from Mg to Mg2 plus, it became more positive. Pb2 plus went from Pb2 plus into Pb, became less positive. So what you can conclude is that Pb actually gained electrons, right? Because by gaining electrons, they remove away the positive charge. Whereas magnesium actually become more positive because it lost electrons. So with your ox gole, which one is being oxidized and which one is being reduced? Ox gole tells you that those that are being losing electron, they are the one that's being oxidized. Okay, so the substance that's being oxidized in this case is your Mg. And how do you explain? Because Mg has lost 2 electrons to form, of course you spell the electrons, to form Mg2 plus. So same thing, I will always have a before, after, and what happens in between. Right? And of course, in this case, the substance that's being reduced will be your Pb2 plus. because Pb2 plus has gained 2 electrons to form Pb. Right? So you see the format is always the same. What happens before, what happens after, and what happens in between. Last but not least, let's take a look at the last question over here on this chlorine as well as iodide. So if you take a look at it again, chlorine went from just Cl2 to a 2Cl minus. Okay, this minus charge tells you it's negative now, which will show that it actually gains electrons. Whereas the I minus to I2 actually lost electron. So similarly, oxgole, how does it work? The one that's been oxidized will be the one that loses the electron. So is your I minus. Do you need to put a coefficient of 2 here? No, there's no need to put a coefficient of 2 because you're just talking about iodide. You're not talking about 2 iodide. It's just 1 iodide. Just looking at 1 iodide. Because I minus lost electrons to form I2. That is a before, after, and what happens in between. The substance that's being reduced in this case will be your Cl2. Because Cl2 gains electrons to form Cl minus. By now you have noticed there seems to be a pattern in the way I write, in the way I deduce the thing. Yes, there really is. But of course all these things doesn't really explain why we learn about oxgole. And it's the last type of method to tell whether there's oxidation or reduction, which is the most important one, and that is based on something that we call oxidation state. The next video will show you about how to use the oxidation state to explain whether redox reaction took place or not.